Today is November 29th, 2011. We're on lesson 6.2. So, the first example, what we're going to go through is isolating variables and three different equations. Now, if you guys notice, in these equations, we don't actually have any numbers. We're going to do the theory behind this. So we're going to be moving letters around. These are all variables. Each of these letters represents an unknown number. Okay? The first formula is A's amount of dollars, and P is principal, and I is interest. So this is actually a formula we're going to talk about later. But what's important is we need to know how to isolate P. Okay? So we're going to move down. 1A, we have A equals P plus I. Separate. How do I do it? And then, so to isolate P, that's right. That means we need P by itself on one side of the equation. We're going to keep it on the right side of the equation, which means we're going to move I to the other side of the equation. Okay? Because it's addition, let's refer to our opposites here. The opposite of addition is subtraction. So when I goes to the other side of the equation, we get A subtract I is equal to P. Guys okay with that one? Simple. B. We have volume is equal to length times width times height. But in this question, they've asked us to isolate H. Okay? So, in other words, we need H by itself, and we're going to keep it on this side of the equation. So we need to move the L and the W. Now, this says L times W times H. So because they're multiplication, when we move L and W to the other side, we have to use division. Okay? So what's going to happen here? We're going to get V is equal to, and when we move the, sorry, I kind of underlined the wrong one there. We want to isolate H, but we're going to actually move L and W. So when we move L and W to the other side, it has to become divided by. So we're going to get volume is divided by length times width. We move them together as a group. Okay? Those two numbers multiplied actually create one number, so we can move them as if they were one number. We move L and W together, and it becomes divided by on the other side of the equation is equal to H. So H is equal to V divided by L and W. So normally when we move something, we'll do these in blue, okay? We're getting rid of stuff. When I move LW, technically I divide both sides of the equation by LW. And what happens is this LW cancels itself out. So we're left with H, and we get V divided by LW. Just like in the previous question here, technically I subtracted both sides. So negative I plus A. These two I's here cancel each other out. I just kind of rearranged this here. We got A subtract I. Okay, what we'll do is show that step each time. Last thing, 1C. In the book, they ask us to isolate for V. We get I is equal to VR, but I would like to isolate for R. It's a little more difficult. Okay? To isolate for V would be pretty straightforward. This is V divided by R. So we would need to move R to the other side, and because it's division, we know R would become multiplication on the other side. Now that would be to isolate for V. We're going to try to isolate for R here. So, anyone have an idea what my first step might be? Okay, so, Jameson pointed out, if we're going to isolate for R, I really don't want R to be on the bottom of a fraction, to be divided by something. So the first step, what he did was he got rid of his fractions. He moved R to the other side of the equation, which is essentially what you would do to isolate V. So, he was moving R over, which means because it's divided by, he multiplied both sides by R. Okay? When he multiplies both sides by r, these two r's are going to cancel each other out, and we're left with r times I is equal to v. But the question asks us to isolate for r. So I got to take this one step farther. I now have to move my I to the other side of the equation. In order to do that, I need to divide both sides of this equation by I. In which case, these two i's will cancel each other out, and we'll get r is equal to v divided by I. Example number 2. Sorry, let's start at the top. We have the formula that converts converts Fahrenheit to Celsius. The question asks us to convert 30 degrees Celsius to Fahrenheit. So essentially the opposite. We're going to need to replace C with the number 30 and then solve. I'm going to do this 2 different ways. One of the ways is I'm going to plug in right off at the bat, and I'm going to plug in 30 for C, and then solve for F, and eventually isolate. In the other example, I'm going to isolate for F first, then plug in for C. Okay? So we're going to do method 1 first. You guys are more than welcome to choose whatever method is easiest for you. It's right there. It's right there. These are the exact same formulas. Okay? So in the first question, method 1, I'm going to isolate for F first. So right now, this is a giant fraction, you could say. There are a lot of numbers on top, and everything is divided by 9. So the very first thing I need to do is I need to move the 9 to the other side of the equation. When I move 9 to the other side of the equation, that means I need to multiply both sides of the equation by 9. That will cancel out the 9's on the right side. What is 9 times C? How can I represent that? 9C is equal to 5 times F minus 32. The next thing we need to do is this bracket here. Remember, when we're moving things, we try to think of reverse bedmass. We have our brackets, but technically the brackets are multiplied by 5. So the 5 is the next thing I want to move over. I want to move the 5 to the other side of the equation. And in order to do that, I'm going to need to divide both sides of the equation by the number 5. When I do that, the 5's will cancel out. We'll be left with 9C divided by 5 is equal to F minus 32. And finally, the last thing I want to do in order to isolate is I want to move negative 32 to the other side of the equation. Now when I do that, I have to add 32 to both sides of the equation. If you can do it in less steps, that's fine. The 32's will cancel each other out. So I'll definitely have F on the right side. On the left side, I'll have 9C divided by 5 plus 32. So now I've isolated F. So this is the formula for converting Celsius to Fahrenheit. Okay? The other formula we started with was converting Fahrenheit to Celsius. So we've created a new formula, something we could hold on to, a faster way to convert. Now remember we said we're converting 30 degrees Celsius. So I'm going to replace the C in this equation because, side note, C was equal to 30. We're going to replace it with 30 and solve for our Fahrenheit. So 9 times 30 is going to give us 270. Plus 32 equals F. This gives us 270 divided by 5 plus 32 equals F. $270 divided by 5 is 54. So 54 plus 32 is equal to F. And finally, 30 degrees Fahrenheit is equal to 86 degrees, 30 degrees Celsius is equal to 86 degrees Fahrenheit. So that was our first method. I'm gonna bring it all up in a second. I want you to check out the next one now. In the next one, we're gonna go right off the bat. We're gonna replace C with 30, and then work through the question. Okay? Some of you might find this a little easier to do. So in the next one, we have 30 is equal to 5 f minus 32 divided by 9. Now, this is very similar to our last one. I'm actually going to move, that 30 looks a little weird. We're going to move the 9 first, just like we did previously. And when I move 9, what do I have to do? I got to multiply both sides by 9 in order to move the 9 over. So right away, we're going to get 30 times 9 on the left side is equal to 5 f minus 32. Okay? I'm going to do two steps here. I'm going to simplify the left side. 30 times 9 is equal to 270. I'll do one. Now that I have that, again, I have to isolate this f. So what will I need to do? I want to move something on the right side of the equation. 5. We want to move the 5, so we're going to divide both sides of the equation by 5. That's going to give us 270 divided by 5 is equal to f minus 32. 270 divided by 5 is, anyone remember? 54 is equal to f minus 32. And the last step will be to move negative 32 to the other side. We'll have to add 32 to both sides, where we're going to get 86 It's a little small, right? Okay, example 3b, we're dealing with volume of a sphere. Is it volume of a sphere? Yeah, volume of the sphere. We need to find the radius of the sphere, okay, which is a three-dimensional circle, essentially a ball, soccer ball, volleyball, anything like that. The volume of this object is 1 meter cubed. We need to find the radius of it. So our very first step, I'm going to use our method 2 from before. And I'm going to replace the volume with the number 1. Because volume is equal to 1 meter cubed, we get 1 is equal to 4 over 3 pi r cubed. Okay? Now, there's quite a few things we need to do here. This is all multiplied by each other. Okay? So, what we're going to do is we're going to move one step at a time here. If I was to multiply all of these together, this could actually look like this. All of this divided by 3. Because when we multiply fractions, it'd be 2 pi over 1 and r cubed over 1. And when we multiply fractions, all the top numbers would be multiplied by each other, and our bottom number would be 3. Okay? The reason I want to show you that, because my very first step here is going to be to move the 3 to the other side of the equation. And in order to do that, I'm going to have to multiply both sides of this equation by the number 3. So 3 times 1 is 3. The two 3's on this side will cancel each other out. Again, because the only reason that's happening is because these are all multiplied by each other. If there was an addition or subtraction in between, it would be a very different question. So the 3's cancel each other out. We're left with 4 times pi times r cubed. The next thing I'm going to move, this will help you, Michael. We'll do the 4 first. Again, because they're all multiplied by each other, I can just divide each side by 4 in order to move the 4 to the other side of the equation. The 4's on this side will cancel each other out. We're going to get 3 over 4 is equal to pi r cubed. Now, I'm going to let you know, what we could have done there is we could have moved 4 and pi at the same time. But I'm going to do it step by step, because we did that in one of our first examples, and I know you guys want to see this broken down. So the next thing I'm going to do is I'm going to move the pi over. In order to move pi to the other side of the equation, again, I'll have to divide by pi. And if you look over here, dividing by pi would be just like extending this fraction and having pi on the bottom half of the fraction. So we're going to get 3 over 4 times pi, we'll just call 4 pi. The pi's on this side will cancel each other out, and it's equal to r cubed. So if I had moved 4 pi together, it would have been like jumping to this step here, and we would have 4 pi below 3, or 3 divided by 4 pi. You want to go now? No. Just wait. Just wait. So the last thing we need to do is we need to move the cube. We need to get r by itself. So I need the opposite operation of the cube. This is where our note comes in handy. The opposite of an exponent is a root. Okay? And essentially what that means is, I'll show you 3 things here. So let's say we had x to the power of 5. This will be our side calculation. X to the power of 5. The opposite of this, we're going to say opposite, can be represented 2 ways. It can be represented as x to the power of 1 over 5. We're going to get into that later. Which is also equal to the 5th root of x. Okay? Now you guys are used to seeing square roots, and a square root means the number 2. And we usually use that. Do a bit more here. For example, if we had x squared, we know that our opposite of this is usually the square root of x. Technically, there's a 2 here. We just don't write it in because it's the most common root we use in that. Okay? But technically, there is a 2 there. And again, that can be also represented by x to the power of a half. So, if I have a cubed root, and I want to write it like this, it's called a radical. If I want to write it like a radical, what symbol would I use? What symbol do we use? This will be our final side calculation. We have x to the power of 3. I need the opposite of this. I want to write it like this. It is x, not a square root, cubed. Okay? So we write, it looks like a square root symbol. It's called a radical. It's called the 3rd root. So in order to move that to the other side, I need to find the 3rd root of both sides of the equation. I'm going to show you how to do this on a calculator. So we have r is equal to the 3rd root of 3 over 4 pi. The first thing we need to do is equate what's inside that equation. So we have 4 times pi is equal to, that's our number on the bottom, 12.5666. So we just figured out what 4 times pi was. We're still looking for the 3rd root of 3 divided by 12.566 is equal to r. What we're going to do here, we're going to divide 3 by that number. So 3 divided by our 12.566. 0.238. So we have the 3rd root, 0.238 is equal to r. Okay. Now we need to find the cubed root of this. This is what it's going to look like on your calculator. you guys most likely won't have a symbol. Well, actually, you might. Let me just double check the shift. Ah, yes, we do have it. The cubed root, it's very hard to see, but that's a 3, which what looks like a square root symbol. It's called a radical. So this is considered the cubed root. If your calculator doesn't have it, you'll probably have an x there. Okay? If you need me to show you how to do it with a calculator that has an x there, I'll show you. It's a little different. So we hit the cubed root, which means we're looking for a number that you have to multiply by itself 3 times to get what's underneath our radical. So the cubed root of this is 0.62. So the radius of this sphere was 0.62 meters.